Hey crew, welcome back. So we are going to be on unit 3 now. I accidentally just filmed this entire video. I had finished and then I went back and realized that I had screen recorded with no volume. So now I'm having to redo it. But it's okay because now I'm just extra well brushed up on the material. So sorry that it has been so long since my last video. I went through a very, very busy time. But I'm now back. And we're going to be doing, for me, it's unit 3, but I know it's a very much a continuation of the last unit with the minimums and maximum sort of vibe. It's definitely, especially today, is about that. So, yeah, we're just going to jump right in, but it is related for most people. It can be related. And today we're doing the extreme value theorem. So, again, it kind of branches off of what we've already done. So, the idea that the extreme value theorem presents is that f of x is continuous on a, b. Note the closed brackets, it does matter. Then f of x has both a global max and global min on that. That's basically all the theorem says. And there are 3 steps to doing this, which is just to check that it is closed brackets, check that it is continuous, find the relative min there, find the max there, and find the endpoints A and B. The reason you find the endpoints is because in an example like this, you could find your relative mins and maxes as we did in the last unit, but you don't actually know what the global one, because here the global one on AB, the global min, is going to be f of b, right? As I wrote here, g min is f of b. And that's just because, as you can see, it is just the lowest on that interval, so you can't only consider. But of course, on this interval, the global max is up here. It happens to also be a relative max. So that's why you need to consider both the relative maxes and the endpoints as well, just so you can then compare their values. So another important thing is that I did say that it has to be a closed interval, but if you were to be working with something that is not a closed interval, then you cannot use the EVT, you cannot use the extreme value theorem, but you can still use global maximum and global minimum more graphically. So for example here, this would not be able to use the EVT because as you can see it's closed on A but open on B because it's undefined at B. So the global minimum here is x equals A, and there is no global maximum because it's undefined at x equals B. So I know that a lot of you guys might be thinking, because I definitely was when I heard this, that, oh, well, there is a global maximum. It's just right here. It's just right before B then, right? Yes, but that is actually a limit because, of course, looking at between these two things, you can obviously tell that the highest point is up here, and so it's a limit getting closer and closer and closer and closer to this point, and we will discuss that later. But notationally, you would say that there is no global maximum, is how you would present that. And then here's an example of where A and B are both open. There's no G max or G min because it would read like A point A plus 0.001, it would be B minus 0.001, but of course, those are limit things, which we're going to talk about later. But here you would say that there's no global maximum and no global minimum because neither of the endpoints are defined. And it's not that you can't use the EVT. Again, even though you can't use, there's a fine distinction here because here you cannot use the EVT and you cannot find any global maximum or global minimums. And here you still cannot use the EVT, but you can still find a global minimum. It doesn't use the EVT because it doesn't guarantee that the EVT, again, guarantees that there's both a global max and a global min. And because this is open, you cannot guarantee there's both a global max and a global min. In fact, there's not a global max, there's only a global min. So that's why you cannot use the EVT here, but you can still find one other thing. So again, just to rephrase, with the even if you cannot use the EVT because of something, you can sometimes still find stuff based on the graph like this one, and sometimes won't be able to like this one. To mention something really quickly that I forgot to say, which is just that if it's constant, and again, constant is not linear, constant is like y equals 3, then the global max is equal to the global minimum is equal to k, or 3 in this case. So I just want to take you guys through this basically like a little, as I wrote at the top, recipe for how you do stuff. It's down here, but first we're going to go over a brief practice problem. So the big idea of this unit is, I would read this is really important, which is just the idea that this is only one step further than the last unit. So in the last unit we learned to find relative extrema, and now we're just using this relative extrema and we're just simply adding on something else, which is that we're going to compare it to the endpoints so that we can find the global ones too. So in the same type of problem, they could be like list the relative and the global extrema. In fact, they usually do. And so this is just sort of adding on one little tiny extra baby step to what we already know how to do. So it shouldn't be too overwhelming. It's not really that hard because you've already built up so many strong skills on how to do it for relative ones. It's not a big addition to do it for maximums, for globals. So for example, we have this. The closed brackets here. And you first start off by just finding the exact same way you would the relative maximums and minimums. I'm not going to go over that because I know that you all know how to do that. But you end up with that x equals -1 as a relative you would obviously should not. This is terribly notated. You should write f of -1 equals 4 is a real max. Is of course how you're meant to write it, since 4 is the y value, which is what you refer to when you say relative max. So I understand, I acknowledge that my notation is not very good here, but that's what you would say. You get these values. Then you have to plug in for the endpoints, which you do simply by plugging in the endpoint and the high point to your original f of x equation, right? Because that's all you're doing. All you're trying to do is get the values on the original f of x that are true. This graph is not accurate. It's for something else. So And we get these values. Then, okay, this again is a technical answer, but it's not how you would actually write it. We're going to talk about how you would actually write it in a minute, but just so we can see that we understand the answers. F of negative 3 equals negative 16 is a global min. F of 1 is 0 is a relative min. F of 1.5 equals 7/8 is a relative min. And F of negative 1 equals 4 is a global max. So it's important because this relative max we found back here is also a global max. It is very possible to be a relative and global, as this one does. And so you can be relative max and a global max. And this one down here, we weren't sure what it was going to be with it. We just found the endpoint, and that ended up being a relative max. Whereas this one, which we also found we weren't sure, ended up being a global max. So it can kind of be anything. Now I'm going to show you the more proper way that you would write some of this. And this is actually really important because this is how you would be graded on. I don't know if you guys are using these videos to study for the AP Calculus exams, but they would expect you to write with this sort of formalities, or even just for your classes or for college or whatever. This is sort of the expected format. So you would write F of negative 3 equals 16, as we found up here. It's a global min since, this is important, this is just the justification, F of negative 3 equals negative 16 is less than or equal to F of x, a, x, e, negative 3, 1.5. So this looks really fancy. I don't know if you guys, my freshman year, and we did geometry, and when we did that, we did logic, and in logic, we use this notation, the AXE things, but all this means is that, all these, this means all x including is what this means. So all of the x including, right? So all this is really saying, if it helps you memorize it, is that you're just saying, since this is the global min, because f of this, which is this, whatever value, is less than or equal to any of the other x values on this interval, right? And so the only way, you don't have to, even though you know that, because if you were explaining it out loud to me, you'd be like, oh, well, I know that because I know what the relative minimums are, and I checked the endpoints, and this was the smallest value I got. Yes, but the way that you express that, because you know that the relative minimums and the endpoints check for any possible, because they're the relative mins and maxes, and the endpoints, that's inherently checking for any of the peak, highest, or lowest behavior. That's the goal of the test. That's how you test it, because it has to change sign. It's a whole process. It's how you tested for it. So the way you say that is that this value is less than or equal to all x's across this, which is obvious. I mean, obviously, a global minimum, by definition, means that it's less than all x's equal to this, and a global maximum means that it's more than all x's in this interval. But logically, to you, that should be like, oh, yeah, you do it by testing the rel maxes and endpoints, and you express it as being less than or more than any other x in that interval. So next, we're just going to go through, the bit of the formulaic thing. If you want to write this down, I would write this down. And then I'm just going to go through a couple more practice problems, example 2 and example 3 on the next page. Okay, so for the formula, this is what you're supposed to do. I would just like to make a quick disclaimer that I do not do this perfectly on the next page because I was kind of rushing, but when I'm doing full formal problems, I of course do this, as should you. So step 1 is to state, and you should state this, the EVT guarantees that f of x has a global min and global max since f of x is continuous. This is stating continuity, but this is the way of phrasing it, is that the EVT guarantees that there's a global max and global min on this since it's continuous on this, right? Then you're going to find the relative extrema and justify. This is what we did in the last unit, right? So this is familiar. That's why it doesn't have any other explanations. The justifications are the same. You should not don't drop the formalities that you had there. Then you're going to find the endpoints, which you just do very simply by this. They don't require very much proof. Then you compare the extrema to the endpoints, which you can do in something like this if you want, or this is a step more of you need to think about it step. There's not necessarily a formal way that you should write that part, that you can do like this in this purple box if you'd want. But what's really important, you could jump right from these two to this last one if you want to do it in your head, is the formal sentence, which again, you're going to say f of negative 3 is 16 is, you don't really say, you read this is, f of negative 3 is 16 is the global min, since f of negative 3 is negative 16 is less than for this function, all the x values across this interval. So you just want to make sure you're following that. And then, of course, you would also want to say, when they ask for the relatives, you would also say, f of 1 equals 0 is a relative min because. So you'd want to formally finish all of your sentences. Okay, so for the sample problem, So let's look at this one first. As you can see in this example, it's across negative infinity to infinity. So note that the EVT does not apply because of the open interval. That being said, we can, of course, still look for a global max and, of course, the relatives. So first, we're going to solve it normally as we would for a relative, and you get that f of 2 is 3 as a relative max, since f prime 2 is 0, and it changes. Blah, blah, blah. We also get that that's a global max, since, again, we have to prove it right, f prime 2 equals 3 is greater than or equal to f of x, a, x, e, negative infinity to infinity. Sort of makes sense conceptually if you look at this, because, of course, if this were 0, if you think about it, like the biggest number that this could possibly be is 3 because this is going to be a negative number. So that should make sense. But then when you go to look for the global minimum, you're like, oh no, there is global min. So this part's really important. This goes back to the idea we were talking about before. Limit of f of x as x approaches infinity is negative infinity. And as x approaches negative infinity, it's also negative infinity. It's just approaching, like f of x is approaching negative infinity from all sides, because look at back here. So when that happens, that means that there is no global min, because it's going to be negative infinity, and negative infinity is not a number, right? And it doesn't approach positive infinity, it approaches 3 up here. But it's negative infinity down here, which is why it's not a number. Down to the next example, it's kind of a similar idea, which is that f of x is x cubed minus 6 plus 2 on negative 3 to infinity. Note that EVT does not apply. So you do the same thing, and then you plug in your negative, whatever, you get your relatives. So you get your relative extrema, and you get your endpoints. But here's where I actually made a mistake. First, let's do the part that I was worried about, which is down here. There is no global maximum, since limit of f of x as x approaches infinity is infinity, right? So that's true, right? So as x approaches infinity, which you know it's doing, it's gonna reach infinity. Therefore, there is no global maximum. And the endpoints, but then here's where it's hard. I'm a little tired. But yeah, that's right about there's no being global max. But for the minimum, first I had said the f of 3 to negative 16 is the global minimum, but it's super important to note, f of negative 3 equals 16 is not defined on this interval. This interval does not encompass 3. Therefore, that's actually not right. So what you actually have to say is that limit of f of x as h approaches 3 from the right. And I say from the right only because it can't be from the left, right? Obviously, because you can see that it doesn't go below negative 3, so it can't be from anywhere except for the right. So then you have to have limit of f of x as x approaches 3 from the right is equal to negative 16. So since here's the way to write this, negative 16 is less than f of 1 equals 0. You write that because you're basically proving why. I'll explain in a second, sorry. Then you write f of x does not have a relative minimum. So you might be like, well, why don't you just say that x equals negative 1 is a relative, that x equals 1 is a relative minimum. Well, this is exactly why. You prove that that's not true, because what you're saying is that it is not defined, but it would be. You're basically like, this number that's not defined is smaller than this other one that is, the other option. And so I can't pick the other option because they have this better option, but this better option actually doesn't work, so there's just nothing. So it would be obviously inaccurate if you think about it conceptually to say that x equals 1, that f of 1 is 0 is a relative, is the global minimum, right? This is supposed to say global, obviously, there's relative minimum. But that would obviously be inaccurate. But the way that you phrase that is you're like, okay, it would be negative 16, but since negative 16 is less than what this is, then there is no relative minimum at all. So yeah, that is the day. Thank you so much. And as always, I hope you all have wonderful days and are looking forward to the next video. Bye. Have a good night.